Here we are once more, our team introducing you to the project submission of CSCI369. The participating students are Israr, Hamza, Bilal, and me, Umar Al-Khali. The project title is an attack chain chaining SSRF and SSTI web vulnerabilities for remote code execution (RCE) in internal network microservices. We do note that the video and the report submission, both submissions are complementary to each other, meaning both of them will give the complete picture of the attack chain. So these are the things we'll cover in the video. That's we start with the project scope and objective. We move to the aim of the project. Then we introduce you to the setup that we use to implement the project. We explain what is SSRF, how the API leaks information. We explain then the Gopher protocol. Then we go and move and talk about the meaning of the SSTI, template elimination inference method, the SSTI payloads. Then we do demonstrate the reverse shell, and we also show the Python automation. In this project, we do mimic the SSRF and the SSTI web vulnerabilities. While the SSRF is ranked number 10, the SSTI is ranked number 3 in the OWASP top 10 list of 2021. Now, both vulnerabilities are server-side, making them even more dangerous than the client-side vulnerabilities in web applications. And due to insecure practices, a developer for your web application may forget to account for certain protocols, specifically the Gopher protocol. The Gopher protocol is a powerful protocol that is capable of sending post and get requests just like the HTTP. The objective of this project is to obtain the RCE through the attack, and at the end is to automate the project with a Python script, meaning that with one click compromise the entire system. In this project, we do shift the gear to an attacker mindset. The ultimate goal is to break down all the pillars of the information security triad, that is the confidentiality, integrity, and availability. Upon the breakdown of all pillars, we call the project a success. For the ethical hacking purposes, we had to develop our own web application for testing and mimicking the vulnerabilities. Since both vulnerabilities are server-side, we require two servers. The first server was made using Express Node.js running on port 3000, while the second server had the MongoDB database running as a service and was running on port 8000. We decided to go as real as possible to the real life, and we have decided to make an e-commerce website for selling iPhones. Now, we required such network architecture. Now, in this network architecture, the attacker was unable to make requests to the MongoDB server. However, what the attacker would do, the attacker approach is to take advantage of the SSRF vulnerability and trick the Express server into returning information from the MongoDB server. The MongoDB server is internal, that is the internal microservices within the organization. Attacker is unable to access. However, the attacker would trick the Express server to return information since the Express server itself is authorized within the network.
What is SSRF? SSRF, or server-side request forgery, is a web vulnerability that allows an attacker to manipulate a web server into making HTTP requests for him. So the attacker would be able to control some kind of parameter that's sent to the server, and the server would make a request to that target domain or without any restrictions usually. This is a huge vulnerability, and it can be used to access internal network. So if the target is a company that has internal network with multiple machines and services, it can be used to access that. If the library supports protocols, it can be used to access files, it can be used to access other localhost services, or it could also be in cloud deployment, can be used to access cloud metadata. Here we have an example of an SSRF exploit. So a server here is expecting a post request with a stock API, and then it takes a web link, and then it makes a request internally. The issue here is the developers did not think that the attacker could change this, and we could. So if we change the stock API to something like localhost, then the server would make a request to localhost/admin for us, accessing something running on localhost only, or bypassing some restrictions sometimes. How to check for SSRF as an attacker? We usually would open some kind of listening server on our machine or on the cloud or somewhere that can be externally accessed. Or we could use a website like website.hook, which opens a listener for that. And we can also use like Burp Collaborator. Then we would give the IP or URL of the server we opened as on the parameter we are testing. And then if our server gets a request from the target, that means the target made a request to our server using the parameter we provided. And that would be an indicator of SSRF, as we have essentially ordered the remote server running on the victim to make a request to a server of our choosing. The Gopher protocol is an early protocol that was designed in the early 1991, which was used for handling documents, sending documents in IP networks. It was an early World Wide Web alternative, but was later replaced by HTTP. Gopher allows us to specify the IP port and the bytes we want to send. So essentially, we can send any type of TCP packet. This is pretty powerful when we're testing for SSRF, as if the remote server allows a Gopher protocol, then we could construct a post request by sending the exact post data, as we see here on the left. The post data that is usually sent by the HTTP protocol, we can just URL encode it and send it using Gopher. And then we essentially are able to send post requests or other kind of requests, even to other services like FTP or SMB if possible. This usually is used to exploit vulnerable internal microservices. Many companies still to this day have a poor job with internal services because they would usually spend a lot on securing the outer network. but internally there's usually lack of security, using of default credentials, or just no authentication at all. This false state of security is usually exploited once an attacker bypasses the outer perimeter of the firewalls, maybe through a phishing attack. They can easily usually escalate. And the lack of security, lack of policies usually is what leads to these vulnerable microservices, which are used by attackers to further exploit our targets.
Now, what exactly is SSTI and how does it work? Server-side template injection is a critical web vulnerability. It occurs when the attacker inserts malicious payload into the template engine used by the web application. The vulnerability it arises when the user input is improperly sanitized. Now, what does that mean? So the attackers, they are allowed to execute arbitrary commands and access the sensitive data, or even gain remote code execution, which is the highest form of the risk. In SSTI attacks, usually attackers they exploit the dynamic nature of template engines, which are designed to render content dynamically based on the user inputs. By injecting different types of malicious payloads, such as mathematical expressions or complex JavaScript code, the attackers can manipulate the behavior of the template engine. When it comes to SSTI vulnerabilities, there are numerous types of templates or malicious payloads which the attacker could use to exploit the vulnerability. For example, here we have the pug template, and we have inserted the payload on our website, and it outputs it as pug. This is a Node.js-based template. And there are other examples of computational or numerical-based templates, which we will be showcasing further in the demonstration. Establishing a proper means of communication is perhaps the most important step for an attacker to be able to exploit the vulnerability and also to ensure a proper cleanup once they're done. So attackers can confirm exploitation by using tools such as webhook.site, Netcat, or Burp Collaborator to receive the incoming communication or callbacks from the vulnerable server. By injecting payloads that trigger outbound HTTP requests or initiate reverse shells, attackers can verify if the template engine is executing their code. For example, a payload might use a curl command to send a request to a unique webhook.site URL, which would prove a successful execution when the request appears on the webhook logs. You will be seeing a similar demonstration in the upcoming slides.
This slide is about a tool called RevShell. It is a very useful online tool which helps us generate reverse shell payloads in different programming languages. On the right, you can see we have used this tool to generate a bash reverse shell payload. We just use the attacker's IP and port, and it gives us the exact command to use. After the script is run, we have RCE achieved, which means we have now remote code execution on the web server.
In here, we'll open the website on the attacker machine, set up the Foxy proxy and the Burp Suite setup. In this project, we're using Burp Suite Professional. That is the attacker machine, and the attacker machine will be logging into the accessing the website. So through the Firefox, we do put into the website IP. Now we get an error that is because of the Foxy proxy extension. Now the website is working perfect, and we are able to access it through the attacker machine.
Hello, and welcome to our demo for CSCI369 project. We're going to be attacking our victim application, which is running on this victim machine, Debian machine. It's running on the IP 192.168.158.146, and it has two ports that we are targeting: port 8000, which is running on loopback interface, and port 3000, which has a web server. We have them running here. To start off the attack, we would usually nmap the target to discover any open ports from an attacker point of view. So we would target the IP -p to not check if it's online, VV for verbose, and N to skip DNS resolution. We find that's only port 3000 is open. We could also launch a more specific scan on that port. -A for aggressive. But it is a web application server. You can see here it's identified as HTTP, Node.js. So we will launch Burp to enumerate the website to find any vulnerabilities. We open the Burp browser, and then we go to the API. It's 146. You see it's some kind of store. It has buying, it has a login. We don't have any logins yet. It has a sign up, and there is some phones. We click on check quantity. It gives back some kind of response. We continue to explore the website, and then after we finish exploring, we have a lot of requests here to multiple endpoints, right? We would be interested in post requests specifically, and this one is a bit interesting. If we send it to repeater, we see here that there's a post in this post request. There's a parameter called stock API, which seems to be taking a URL. Now, usually when a parameter is taking some kind of URL, it's an indicator that the server is making the request, which would be an SSRF vulnerability. But how do we test that? So to test that, we can open a quick listener, for example. So we listen on port 1, 2, 3, 4, and our IP is 128, right? And then if we try this, for example, if we change this to make it HTTP on port 1, 2, 3, 4, and we could actually also add a /SSRF. So it's just a bogus request to our machine to confirm if SSRF is working. And we see it is. We got a connection from 146 on our listener, which is an indicator that there is an SSRF. After confirming SSRF, we could try to hit local services or local and find any services that are vulnerable on the website. So we know that localhost works because that's the original request. And we want to enumerate multiple ports, right? So it would be like /1 maybe, something like that. And then we would like to send this request. We get an internal error. And we get an internal error, but if we hit, for example, on port 3000, which we know is running a web server, we get a response. That means if we hit a closed port, the server responds with an internal error.
At here, this is the vulnerable parameter in which we are able to do the SSRF. Now let's try to access let's try to scan the microservices, ports within the organization. We utilize the sniper attack. With the sniper attack, we're going to be sending repeated requests. So we set the payload on the local host. We do scan. That is to 65535. That is the number TCP ports has. On the local host, we try to check the number of ports, the number of open ports running on the local host within the internal organization. So we now need to start the attack. When we start the attack, the burp suite professional is not throttled, so it does go fast. And in here, so there will be an abnormal response. The abnormal response would indicate an open port within the sniper attack. So let's wait for the attack for the scan to finish. And majority of them would return a status code of 5000, meaning there is an error and it is unreachable. So, however, we should look at the status code where we status code of 200. Status code 200 would indicate an open port, so the CPU utilization is gone very high because of the fast number of requests we are sending the internal microservices. Now here we do get 2000, so 200 at these ports, so port 3000, port 8834, and 8000, which indicates that we have these open ports. We now pause the attack.
And we send this request. We get a status 404 message API/help for help, which means there's some kind of API running. So we can try to make a request to /API/help. Come here, /API/help. Send the request. We get the JSON response here. Status goes 200 message. For more information about the module, please post with the requested module and gives us a list of modules. And so we need to send a post request to know more about a specific module like admin. Post requests are a bit trickier because usually with SSRF you're limited by the remote. But if some remote applications are running curl instead of to make the request, we can use SSRF. And if we check here, when we were checking for SSRF, we know that the library the server is using is libcurl, which should support a protocol called Gopher. Gopher is a protocol that allows us to send base packet structure, which allows us to send post request essentially with the over HTTP for SSRF. To do that, we have like a sample post request here, and then we would need to it needs module admin. That was the requirement identified here. Module users as a JSON body. If we will also need to change the content length. So we need to change the content length of this, which is 25. And we're hitting localhost 8000. The other issue now is this is both. We need to URL encode it and then add as Gopher. So Gopher would be, we would do Gopher, for example. Then we would have the IP, right? I want to make it on port, the target port. So it's port 8000. Then we have a character, and then we have our actual post request here. So, but the actual post request needs to be encoded. For that, we have made our own script, which basically gives us the Gopher request by. So this is the Gopher request that would be requesting port 8000, and this is just the URL encoded part of our payload, which is this is just encoded for URL, so we can send it over over perp. So if we add this as our target, we're also gonna need to URL encode this one. So we do this by selecting convert selection, URL encode key characters, and we send this request. So we send this request, and after a while we get a response telling us that giving us the list of methods for the user, and there's an API admin help for the specific which gives us more help and gives us a list of all of the methods we can use. Some interesting methods we can look at is update pass and create admin. Update priv as well, which would indicate if you create a normal user, you can update the privilege, but we will be looking at create admin. To go back, we try, so instead of this, we will try admin help, and we send request to this. We see that it gives us, in a way, all of the functions. So the developers, when they did that, they meant for this API to be internally only, and that's why they did not secure it. So we care about create user, which has some kind of so we can actually just look at it better if we have something like this. And we have create user. It takes a post request, and that's the payload it expects. So we need the username, email, and password. And so if we come back to here, we can have some kind of request like this. We give the username John, any email, doesn't matter, and the password. And this would be our post request. Then if we encode this with Gopher, same way as before. And then we take this, we go back to perp, we put this here. And then we're gonna encode you, send, wait a bit. We get 201 admin created. So create an admin with the credentials John and hacked. So if we go back to perp, we go to login. We go to John at test.local and the password hacked. We see that we have access to the admin dashboard.
So before we showcase the SSTI attack, we will first identify the vulnerability on our website. So we begin with logging in as the admin on the website, which is hosted on port 3000. Once we log in, we get access to the admin dashboard. Now on the right, you can see the manage promo codes form. We will be showcasing the vulnerability using this functionality. So just to show how the functionality works, we are creating a few sample promo codes. Now you can view the promo codes below, and you can also view this on the client side page. And we'll create just one more to confirm that it works properly. Yeah, and you can view this again on the client side page. Now to identify the actual vulnerability, we will be using the most commonly known payload for SSTI, which is multiplying 7 by itself. Now there are obviously different formats, there are variations which we can try out until we achieve the desired results, which we will see in a bit. So we try the different formats. And eventually, when we try the hashtag format, we achieve the results. Now, how do we know we have identified the vulnerability? Is when the website, it computes the output as its actual numerical value, which would be 7 times 7, 49. Now, this clearly indicates that a vulnerability for SSTI is present. Now you can have a look at the flowchart as well, which we showcased in the previous slides. There are usually two branches. One would be about the comments payloads. Now, if the website identifies a comments payload, then it would probably indicate Smarty template engine. Otherwise, you have the string manipulation payload, which would identify a Mako template engine. And on the other branch, which we clearly showcased on our website, it would indicate Twig or Jinja 2 template engine formats. Next up, we will establish a proper communication with our website to be able to exploit the vulnerability. So we have the listener running over here, and we are using Web Suite to intercept the traffic, and it has the payloads over there. And we are also using webhook.site to be able to view the GET requests when we execute the payload. Now, in the payload, we need to ensure that we have the webhook.site URL, and this can be pasted on our website in the promo code field. And let's make sure we have all the correct details entered in the respective fields. So once we are done entering that, we can move on to the client side page. And when we reload it, we are able to see the traffic on the webhook.site page. The times we reload, we can see the GET request here on the webhook.site page, which shows the successful functioning of the vulnerability exploits.
Here we can see we are using the ref shell generator. We use the IP and the port of the attacker. to generate a command for the reverse shell in the bash programming language. We copy this command, we check it, it's working fine, and then we can copy it into the main template. The payload, we replace a part of the template with the reverse shell code which the website gave. We then run this payload on the admin panel of the web server. We can now see that in the terminal we have the remote code execution, and we can list the directories as well as see the different files in the web server. To automate the kill chain, we use a script in Python named exploit.py. It sends 6 crafted HTTP requests to the web server before we can establish a reverse shell. We run the script by using the victim's IPM port and the IPM port for the reverse shell. We run the exploit.py script. We send the 6 HTTP request packets from the testing connection, exploiting SSRF, creating the admin, logging in as the admin, injecting SSTI, and triggering the reverse shell. We can see we now have the RCE. We can see the password files and the users, and we can also list the directories in the web server.